A sequence of integers x1, x2, x3 all the way up as far as xk is defined recursively as follows. x1 is equal to 1 and xk plus 1 is equal to xk all over xk plus 2, and k is greater than or equal to 1. First of all, we'll have to calculate x2, x3 and x4, and then using this information we will find and prove by induction a formula for the n term xn in terms of n, for all of n is greater than 1. We will also calculate x10 to check that it works. So first of all we will calculate x2 using the formula given in the question, and in part of the question we were also given x1 is equal to 1. So using x1 is equal to 1 we just replace it, subbing 1 in for x1. As you can see here, it becomes 1 all over 1 plus 2, and x2 then is equal to 1 over 3, reducing nicely and easily. For this x3 we will do the exact same. This time we have 1 over 3 for the x2 which we just found, so we will replace x2 with 1 over 3, giving us 1 over 3 all over 1 over 3 plus 2. On the bottom we must try to find the common denominator between the two numbers, which in this case is 3. 1 over 3 plus 6 over 3, and since we have a common denominator in the bottom we can add them easily. 1 plus 6 is equal to 7, giving 7 over 3, 1 over 3 all over 7 over 3. Now we must divide the fraction, and through this we simply flip the bottom and multiply. So as you can see it changes to 1 over 3 times 3 over 7, top by top, bottom by the bottom. 1 by 3 is 3, and 3 by 7 is 21, which reduces to 1 over 7. Same again now for x4, but this time we just use 1 over 7 and replace x3 with 1 over 7. So x4 is equal to 1 over 7 all over 1 over 7 plus 2. We use the same idea here, common denominator, 1 over 7 plus 14 over 7, and this makes them easy to add, giving us 15 over 7. So 1 over 7 all over 15 over 7, and we flip the multiply again. 1 by 7 is 7, and 7 by 15 is 105, giving us 1 over 15. So we have now done the first part of the question. We've calculated x2, x3 and x4. So x1 is 1, x2 is the third, x over 3 is 1 over 7, and x4 is 1 over 15. That's our first part done. We will now attempt to do the second part of the question, which is, using the information in part 1, find and prove by induction a formula for the n term xn in terms of n for all n's greater than or equal to 1. We will then calculate x10. For this we will let xn equal the term n. So here are the first 6 terms of x. x1 is 1, x2 is the third, x3 is the seventh, x over 4 is 1 over 15, x5 is 1 over 31, and x6 is 1 over 63. So we have xn is equal to 1 all over the denominator, and we can try to find a pattern between these denominators, which are 1, 3, 7, 15, 31 and 63. Then the sequence is quite similar to 2 to the power of n, which is 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8. And if we simply take away 1 from 2 to the power of n, we have the same sequence. So we have 2 to the power of n minus 1. For example, 2 to the power of 1 minus 1, 2 minus 1 is 1, 4 minus 1 is 3, 8 minus 1 is 7, 16 minus 1 is 15, and so forth. So now we can use 1 all over 2 to the power of n minus 1. And we're going to use induction to prove this. So just a thing to note, when proving by induction, we always prove the first term, which is n equal to 1, to prove it works. So we sub in 1 for n, giving us 1 all over 2 to the power of 1 minus 1, giving us 1 all over 1, which is of course 1, and that is correct. When proving by induction, you just assume that pk is true, it's taken for granted. So we let pk equal 1 all over 2 to the power of k minus 1. But we must prove k plus 1, which is 1 all over 2 to the power of k plus 1 minus 1. So we will sub in our formula for xk into the original formula given in the question. So xk plus 1 is equal to xk all over xk plus 2. So pk plus 1 is equal to 1 all over 2 to the power of k minus 1, all over 2 plus 1 all over 2 to the power of k minus 1. And if we multiply 2 by 2 to the power of k minus 1, we can turn what's under the line into a fraction in order to make it easier to simplify. We can see here we have them over a common denominator. Minus 2 plus 1 is minus 1. The top set is the exact same. So we have 2 times 2 to the power k minus 1 all over 2 to the power k minus 1. We divide these. When dividing, you just flip the bottom of the fraction and multiply. So for example, 2 times 2 to the power k minus 1 goes on the bottom, and 2 to the power k minus 1 goes on top. We can see these two terms are the exact same, so we can cross them out, just leaving 1 all over 2 times 2 to the power k minus 1. And by the rules of Indice, we can add the powers when the two base terms are the same and being multiplied together, which is just simply, if we were multiplying 2 by 2 to the power k, it's the same as 2 is the same as 2 to the power of 1, so we can just rewrite it as 2 to the power of 1 plus k. This is the formula we had at the very start, so this proves that this is true. And since p of k plus 1 is true and p of 1 is true, our formula is correct for all of k is greater than or equal to 1. Now we must try to find x10, which is the final part of the question. So we know xn is equal to 1 all over 2 to the power of n minus 1. We must sub in 10 for n, giving us 1 all over 2 to the power of n minus 1. And 2 to the power of 10 is 1024. So x10 is equal to 1 all over 1024 minus 1, which is 1 all over 1023. And that is the question.
Block professors, we break down math. What's good? You know what the science is. It is what it is. It is what it will be. Nigga. Yeah. Straights. You learn something new every day. You heard? Yeah. Remember how it got shot? Blood stain on his clocks. He felt the pain when the bullet traveled straight through his